Okay, good morning. Welcome to
FamilyMath423.
FamilyMath423. So I asked you each yesterday what you thought the most beautiful math you had ever seen was. And you said the fourth dimension, right? And what did you say?
The Mandelbrot fractal.
The Mandelbrot fractal. Well, that's cool. We actually, I don't think, have done a project about the Mandelbrot set. So I thought we'd do one today. Just a little bit, because it's actually some really cool math. It's not just a pretty picture. It's some really cool math. So, how you make the Mandelbrot set is you start with a number, a complex number, a plus bi.
Yeah.
Okay. And we're going to call this number c.
C.
Okay. So just c usually stands for constant in math. And it's been like that for a long time.
Okay.
Been constantly true. Okay. And so what we do is we're gonna create a map where we start in the beginning with c, and then we just create new numbers. But I'm just gonna call these numbers z, and we go to z squared plus c. And the reason I have all these variables hanging around is the constant always stays the same. Okay, that's always our starting number.
Yeah.
Okay, and we just keep looping through
So
this every time we have a number, and we start with the constant, but it changes over time.
We square it and add
We square it, add c, and then we go back,
and square it.
So it's
square
just
and add c.
a big loop.
Yeah, and what the Mandelbrot set actually is for every point you start at, either this is going to go to infinity,
Yeah.
or not go to infinity. And the Mandelbrot set is the points that do not go to infinity. Okay. So, for example, let's pick what's the simplest number we can think of to start.
For C?
Yeah.
How about 0?
Yeah, 0. 0 is a great one. So if we just pick 0 plus 0i, which is otherwise known as
0.
0. Okay. What happens when I square 0?
You get 0.
0 times 0 is 0.
Okay, now I got to add 0 to it. So what's my new number?
0.
0. Okay, so now I'm back here starting at 0.
You square 0.
Square 0 and add 0, our original number. And I get,
0.
and so I keep doing this. Does it ever go to infinity?
0 doesn't go to infinity.
Okay, so since it does not go to infinity, 0 is part of the Mandelbrot set.
Cool.
Okay, now let's look at another. Let's pick another really easy number.
How about C equals 1?
Ah, okay. So we're going to start at 1 plus no i's.
So that's
Okay.
1.
Okay, so c is 1. That's our starting number is 1. Okay, so I square 1, I get,
1.
and I add 1 to it. What do I get?
2.
2. So now I'm back here with, now I'm starting with 2, but c is still 1. I'm adding 1.
So 2 squared is 4.
Plus 1 is?
5. So this is going to go to infinity.
Alright, how do you know?
Because it's getting bigger all the time. And you just keep adding things to it.
Okay, so 5, when I put 5 in here, it's going to go to
26.
25 plus 1, 26.
And 26.
And then it's just
squared.
getting bigger and bigger and bigger. So 1 is one part of the Mandelbrot set?
No. It goes to infinity.
1 goes to infinity. So we found one number that's in it, 0 plus 0i, the origin. 1 is not in the Mandelbrot set, which is interesting.
So maybe some numbers that are like in between 0 and 1 are in it. Because all the numbers bigger than 1 will go to infinity.
Ah,
Because they'll all do the same thing. Their squares will keep getting bigger.
okay. All right, so why don't you pick one more number and we'll try.
How about -1?
Okay, -1. That's a great one to try. All right.
Or -1?
Oops, sorry. Minus 1 plus no i's. Okay, so -1 squared is
It's 1.
1?
plus -1 is?
0.
Okay, so I start at -1 and go back to 0. 0 squared?
Is 0.
0 plus
-1.
gets me.
Back to
-1.
back -1. So
Okay.
This is
This
not
is
going to go to infinity.
Can you explain why?
well, because it just keeps going from 0 back to -1, then to 0, then -1.
Yeah, so this -1 has a very interesting property that it just seems to, it doesn't stick on one number like 0 did, but it
It's-
also doesn't go to infinity.
It sort of loops back.
Yeah, it sort of loops. Okay. So now for the second part, we'll take a look at some just a few more numbers, maybe some slightly more complicated numbers.
Okay.